look at is minimizing the distance. You'll see these problems from time to time. And we want to find the point on the curve y equals 1/2 x squared closest to the point 4, comma 1. Now I have the picture here, but if you didn't have the picture, it'd be helpful to draw the picture. You have your parabola, you have the point, and you have some unknown point on the parabola, and you want to minimize this distance right here. Call that d. All right. So the distance formula, since we're speaking of distance, that's the quantity we want to minimize, is x2 minus x1 squared plus y2 minus y1 squared. What we're going to do is we're going to let the point that we don't know be x2, y2, and the 4, 1 is going to be your x1, y1. Okay, so this is going to become equations, or excuse me, the variables x and y are related by the equation y equals 1/2 squared, 1/2 x squared. So I could substitute that in for y here, and this is going to give us the square root of x minus 4 squared plus 1/2 x squared minus 1 squared. So we could call this distance a distance function, if you will. Okay. And then we can FOIL everything out. So the x minus 4 squared is going to be x squared minus 8x plus 16 plus the 1/2 x squared minus 1 is going to FOIL to 1/4 x to the 4th minus x squared plus 1. Okay, all that's still under the radical. And then if we simplify that, clean it up a little bit, you'd end up with 1/4 x to the 4th minus 8x plus 1, or excuse me, plus 17. Now the domain is the set of all real numbers because this quantity right here is always greater than or equal to 0 for all x. Now, since the square root function is increasing for all real x, you only have to minimize the quantity inside here. So we're going to differentiate that with respect to x. So the 1/4 x to the 4th minus 8x plus 17. The derivative of that is x cubed minus 8. Set that equal to 0, and we get the only critical number of x equals 2. You wouldn't have plus or minus 2 because it's cube root, not square root. Okay? So then we can use that critical number to create two intervals. Now you could do a sign chart here when x is 2, and then you could test x equals 1 and x equals 3. Okay, so f, or I guess we're going to use d prime of 1. So if we plug 1 into the derivative, you would get -7. That's less than 0. And then d prime of 3 cubed is 9. Minus 8 is going to be positive, so that's greater than 0. So we're essentially informally doing the first derivative test. So we could say, since x equals 2 is the only critical number, and d is decreasing for x less than 2 and increasing for x greater than 2, the distance function has an absolute min value at x equals 2. All right, you'd want to write that out in words, especially if you were taking the AP exam. Okay, so the y value is equal to 1/2 times 2 squared, which is 2. So the point is 2, comma 2 that minimizes the distance. Okay, so this point is 2, comma 2, and the distance right here is minimized. Now you could plug those values back into the distance formula to find what that actual distance ends up being. All right. Well, hope that was helpful to you guys. Take care.